Okay, before we talk about example 3, let's look at this concept of fundamental theorem of algebra. So finally, we look at the fundamental theorem of algebra. This is very important, so that's why it's called fundamental theorem of algebra. So let's first read this. If p of x is a polynomial of degree n greater than or equal to 1, then p of x equals 0 has exactly n solutions in the set of complex numbers. So in other words, a polynomial equation can be factored into n linear factors, where each corresponding to a root of the equation. So they're related. And then if p of x has any factor of multiplicity m, count the solution associated with that factor m times. For example, the equation x minus 3 to the power of 4 is equal to 0 has 4 solutions, each equal to 3. So they could be repeated. And this is very important because it guarantees the existence of roots for polynomial equations. And then you can figure out the solutions, right? So if you don't even know if you have more or less roots, then it's really hard to figure out all the possible solutions when you think there are a lot more possible solutions. But really, you only have exactly n possible solutions. Well, n solutions, to be exact. Whether or not it's complex or real, there are exactly n number of solutions that corresponds to the degree of your polynomial. So this theorem is also used in various areas in math, not just algebra, but also mathematics analysis, and also a big part of geometry. So it's very important. And you'll see this over and over again if you ever take a math course in college or any other courses after Algebra 1. So very important. Highlight and put stars over it. Very important. Okay, let's look at example 3. Find all complex roots. What are all the complex roots of the polynomial equation? Let's look at this polynomial. 3x fourth plus 4x cubed plus 2x squared minus x minus 2 is equal to 0. And now we know that the degree is 4. We know there are exactly 4 different or same roots. And they could be repeated, or they could be real or imaginary roots. And it could be complex, right? So first of all, you're going to look at the constant term and its factors. Whoops, not just negative. And then you're going to look at the leading coefficient, 3. And then you're going to list all the possible factors, all the possible rational roots. So we have plus or minus 1 over 3, plus or minus 2 over 3, plus or minus 1, plus or minus 2. And then after you plug it in, you see that, if we plug in 2 over 3 or in negative 1, it becomes a 0. So this equation is true when we have these two numbers. So these are roots. You're going to divide using synthetic division to get another factor. So if we divide by 2 over 3, we get 3x cubed plus 6x squared plus 6x plus 3. And so we can rewrite our equation, our polynomial, using these two factors. And then now we have a new polynomial where we want to factor out further. If we factor this out further, well, first of all, let's factor out the GCF, which is 3. And so then we have x, or, actually, let's divide this by plus 1. And then you'll see that it's going to have a factor of x squared plus x plus 1. Because this is the special polynomial. Remember from the Pascal's triangle, 3, 6, 6, 3 is the first row, right? Yeah. So then you can just easily divide by -1. And then you're going to have multiple factors, right? So after you factor out DCF, you have x cubed plus 2x squared plus 2x plus 1, and so that's the Pascal's triangle. And so you're going to use the first row and then factor it out. And then you're going to use the quadratic formula to find the last two roots. If you use the quadratic formula for this last polynomial, x squared plus x plus 1, you know that your discriminant is negative. So use the quadratic formula, you'll get two complex solutions. So for this polynomial, you have two real solutions and two complex solutions. Yeah, and so this is degree 4. So we have all 4 roots. So now we're done. The fundamental theorem of algebra states that these are the only 4 roots of the equation. Good. So now let's look at try number 3. And now it's your turn. What are all the complex roots of the equation? X cubed minus 2x squared plus 5x minus 10 is equal to 0. So pause the video, follow the steps that we just did in this example, and come back when you're ready for answers. Okay, are you ready? All right. Yeah, let's look at factoring this out. So first, look at the constant term, -10, and your leading coefficient 1. And so this, since q is going to be 1, it's just basically your factors of -10, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. And so from these, you'll find that 2, positive 2, is going to be one of your roots. So use synthetic division to divide to -2, because if your solution is 2, oh wait, no, not -2. Divide by 2, yeah. And then you're going to write the coefficient 1, -2, and then 5, and -10. And so put down 1, multiply, and then add, multiply, add, multiply. Did I forget something? Oh, this is 0. I'm so sorry. So if you multiply 2 times 0, it's 0. So that's 5. And 2 times 5 would be 10. Yeah, there we go. So then you have 0 remainder. Good. I know this is going to be a root, so then it shouldn't have a remainder. Okay, and so you can rewrite this as 2 factors, x plus 5. Wait, x squared plus 5 times x minus 2. And then we already know that x squared plus 5 has a discriminant of negative. So it's going to have complex roots. So use the quadratic equation, and so here in this case b is going to be 0. So you're just going to have 0 plus or minus 0 minus 4ac, and then all over 2 times a, right, which is 1. Okay. And then you will see that it's going to be -20, root -20, and then over 2. Alright, so that's 2 root 2. Yeah. 2 root 5. 2 root -5. Which is 1, and then I plus or minus I root 5. Yeah. Okay, there we go. Yeah. And so we have this is a polynomial of degree 3. So we have found all the possible roots. So 2, and I'm gonna list out the final roots. 2 and the complex roots. -1 root 5, and then I root 5. These are the 3 roots from this polynomial. All right, check your answers and see if you got it right. If you did, great job. This is example 3. We'll continue with the next example in the next video. Bye.